Hello, everyone. I'm Jan from Trezor. I'm in Trezor and the product team. I'm responsible for the firmware and connect products that we have there. And today I want to talk about the clear signing and transaction simulations and how it is important and how does it work. But let me first start with the thing that I think majority of you remembers from last year. There was a Bybit hack in February where almost $1.5 billion were stolen in just one transaction. And Bybit, one of the biggest exchanges on the world, they had all of the security measurements that one can potentially have. They had different hardware wallets from different vendors. They had multi-sig processes set up. The professionals that were signing the transaction were trained. So how it happened? It happened because of one simple reason, and that is that they signed something they didn't understand. It wasn't failure of technology. Everything worked as expected, but it was a failure of understanding. And the Bybit is not the edge case. It's, of course, one of the, I think it is the biggest thing that happened in this field last year, but this is how DeFi currently works. And usual people can sign this almost every day. Just another example, almost $500 million were stolen in 2024 just because of unclear instructions on the signers. But you can see it everywhere. If you are doing some swaps on DEX, you don't actually know if you are approving a swap or if you are approving some drainer contract. The same with the token approvals, where you don't know if you are approving 10 USDC or a million. Permit to NFT approvals, bridge calls, account abstraction. Everywhere we are seeing that people are blind signing. So why hardware wallets cannot catch those things and why it cannot display the things that people can understand? I just want to recapitulate on what hardware wallet is and why are they there? Why we have them here? So hardware wallets are a single-purpose device that was created by Trezor in 2013, and they had one job. They generate private keys and store them offline without anyone from the internet or without any contract or malware can access the private keys. Trezor, or any hardware wallet, should have a trusted display, and it works as what you see on the display itself is what you actually signed. So there is no way how the hardware wallet can sign something different than it is displayed on the display. And last thing, why it's really important is that no one that it needs a physical confirmation of a human to do any action. So neither some malware or in current world AI agent can approve the transaction for you. You are the point of you are still in the loop, and this is important. So let's take a look how the transactions looks like on the hardware wallet now, and they might look like this. What you see is some arbitrary data in a hex format that is perfectly fine for the EVM, but they're not really fine for the user, because users cannot know what this transaction will do, what they are actually approving, like no amount, no recipient, nothing. And to be honest, like we are now forced to use this because there is no any other way. So the problem is that like you cannot do an informed, or you cannot make an informed decision from the screen. So even if you have a hardware wallet and it's still good because your private key cannot be stolen, you are still blind if you are signing transactions like this. Let's take a look. How does the call data looks like? I hope you see that. So this is an example of how such a transaction of swap on Uniswap V3 from 5 USDC to 5 USDT might look like. The data are in the hex. So let's take a look on them. First, 4 bytes tells you what functions will be called. Then there are other info like token in, token out, fee, recipient of the swap, some deadline, amount in, and amount out. So the data are already there in the hex format, but users don't usually know how to read hex formats. It's meant for the Solidity language, and it means for the EVM. So how such a hex call data can be translated to human readable format, so humans know how to that humans know what to actually confirm. There are several layers. The first one is ABI. It stands for the Application Binary Interface. And this is produced together with the contract in the Solidity compiler. And it helps you to decode the raw call data to something more understandable. So if you put your contract into Solidity compiler, it will give you this ABI. And then you can take then you can see that from the raw hex data that don't have any value, any sense, you are starting to see something. So as I said, from the first 4 bytes, you see the functions, and then you can see that token in has this contract, token out has this contract address, and amount in, etc. But the problem is that even like this is much better than the raw call data, you still don't know what you are actually approving because users don't usually know how many decimals such contract address has. So it's really it doesn't give you any advantage because you are still approving 5 million units of this contract address, which is not really great. So that's where the ERC7730 comes in. And what the 7730 do is actually it sits on top of the ABI, and this is standard which creates how the metadata for every contract should look like. And it tells you, or it tells the users, how should the metadata decoded by ABI should be showed to the user. This is an example how such metadata may look like. And if the ABI decoded metadata are decoded with the 7730, or if the metadata are used, then it can look like this, that users clearly see what they are doing, that it is swap. You are swapping from USDC to USDT. It's 5 USDC. And you see clearly the recipient and the contract. And it might, and it soon will, look like this on hardware, or I hope every hardware wallet. However, clear signing, it's not a single silver bullet. There are several problems. So, as I said, the 7730 creates a registry which contains the metadata for every contract. And these metadata have to be created by a human, and they have to be uploaded to such registry. And if the registry doesn't contain any metadata about the contract, then it will still fall back to blind signing. Another thing where this is not enough is that even if the metadata are created by someone, but the contract is upgradable and gets upgraded, you see something different than you should on the hardware wallet. And last thing, even if the clear signing and everything looks nice, you can still confirm some malicious contract that will, for example, drain your wallet. So clear signing makes transactions readable, but it doesn't make them understandable. You don't know what will happen after you actually confirm and broadcast the transaction to the network. And that's why we have transaction simulations. Transaction simulations, what it does, the provider or the wallet that supports transaction simulations take your transaction and runs it against the current state of chain in the sandbox. So you don't really, so you see what will actually happen. And it will tell you what will you actually approve, what will actually happen. So if you are signing swap, you will see that you are swapping 5 USDC to 5 USDT, and you are not approving any malicious contract. And it catches, for example, the drainers or unexpected amount allowances. And currently, it is in the majority of the wallets out there, as well as in Trezor Speed, which is our companion app for Trezor hardware wallet. Clear signing, together with transaction simulations, provide a very good security upgrade for the end users. The clear signing explains intent before signing, and the transaction simulations tells you what will actually happen if you sign it. So together, they are very good. They are making the security for our users better. Basic understanding of how EBM works remain essential. A clear signing standard wasn't done by Trezor. The foundations were laid by Ledger more than 1 year ago, and then it was further refined with the working group under the Ethereum foundations. You can see the registry on the GitHub, and if you are the developer or builder, please register your contact. It will make the whole ecosystem safer. If you have any questions and ideas, collaborations, please catch me out. Thank you very much.